Okay, so you guys are good with absolute value equations? It wasn't too bad, was it? One thing you got to remember, a couple of tricky things going on. Always get the absolute value by itself, right? Then split it up. See, k minus 10 equal, I like to put the negative numbers first, -1, or k minus, is your phone out? No, I didn't think so. Or k minus 10 equals +1. Add 10 to both sides. You got to solve each one separately, right? Add 10, add 10. Here we get k equals +9, or correct, or k equals 11. And we don't have to worry about graphing it because these are just points because of the equal sign. What do we have to watch for with absolute values? I mean, that would save you some time. Yeah, when you have the absolute values equal negative, yeah, that can't happen. Okay, anything that comes out of absolute value when you drop the bars has to be a positive number.
So what if it's like x minus 20 equals -7?
It doesn't matter. Okay, so -9 minus 6 is -15. You have to take the positive. So it's going to come out of there +15. Right? So there are no solutions. There's not a number in there that's going to ever be a negative number when you drop the absolute value bars. Why is that? Why is it that anything? Why is it that anything in the absolute value comes out positive in this scenario? What's the definition of absolute value? Anybody? The definition of absolute value? Why? I'm looking for one word. Why is it positive?
Just
Distance from 0. It's distance. We cannot go -2 feet to the bathroom, right? Oh, there you go. We'll just walk backwards. No. Okay. So there's no solution for this. And then number 6, I told you to multiply by 3 first. That was on the other sheet, 1 through 4.
Oh, this one we had to do. Oh, I did.
So that you cancel out that denominator. Well, I'm losing my voice. Probably. Hope I'm not getting sick from you diseased people. Okay, so the fun with equations, absolute value equations, let's do something funner. Yes, it is. I made it up. Isn't that great? We're going to do absolute value inequalities. So turn to 1.6. And as Bob Seeger would say, turn the page. Get it? Get it? Yeah, you guys probably don't even know Bob Seeger. But doesn't Metallica redo it? Turn the page. You don't even know Metallica.
I know who Metallica is. I just don't listen.
All right. I'm gonna have to prove it to you later.
See, I told you, don't get confusing. It's on the lot end.
Okay, we're good. I'm gonna lock you in. Okay, so if you did 1.5 part 2, if you did the homework or if you took notes in class instead of playing on your phones, this should be easy. Okay. The only trick here is you've worked with and or problems, right? Yeah. Okay, you have to figure out which one it is. Whereas as in 1.5 part 2, the compound inequalities, they gave you it. Okay. So you have to come up with those conjunction rules. Now, when you have a less than or equal to, less than or equal to, it's and. Okay, when you have a greater than or equal to, it's an or. Now notice, the absolute value term is by itself. Okay. After the absolute value term is by itself, then you determine whether it's an and or problem, right? After it's by itself. For instance, number 3 here, the absolute value is not by itself. So you would have to subtract 8 first, then determine whether that's an and or.
Would it flip the sign?
In this case, no. But if it had like coefficient, negative coefficient, yes.
So I'm gonna isolate the whole number before I isolate the absolute and then absolute variable. And then isolate the variable.
Yes. I think if I understand you correctly, yes. All right, so let's do the first one. The absolute value term is by itself, so I'm going to determine that this is a less. That's okay. I'm going to determine that it's an and problem because it's less than. By the way, my other class had trouble. Hey, what's less than and which one's greater than? If it's pointing to the left, it's a less than, correct? If it's pointing towards the right, it's greater than. Okay? I don't know how your elementary teachers taught it. Yeah, they did the alligator thing when I was a kid. Okay, so we determined it was an and problem, and we're going to solve these separately. So this one, the first thing I'm going to do, subtract the 7. So I get 2x. Good. Now I'm going to divide by 2. So these cancel. I get x. I'm dividing by a positive, so I keep the sign. 2. That's part of my solution. And solve it over here. Minus 7, minus 7. 2x is greater than negative 18. Gonna yep. Yep. So x is negative 9. Do I keep or flip the sign? Keep it. Okay. I can divide a negative number, but I'm dividing it by a positive 2, so the sign keeps. If that was a negative 2, I would have had a flip. So, that's my solution here. Yeah, that's my solution. Okay, with inequalities, we have to graph them. What's my smallest number? And the largest? This is an and problem. Which way am I going to shade? Inside. Remember, and problems. Yep, they're both parentheses. Good. Yep. Remember those Venn diagrams I was showing you? And problems have to be in both, right? Yeah, the or problems, which is the next one we're going to do, that Venn diagram are the outside ones, right? Okay, so let's do an or problem. It's not 100% technical, but it kind of looks like our or graph. We can get really technical and say, well, hey, these actually do work because, never mind. Let's just stick with this, okay? So I'm going to go ahead and solve them. By the way, do you notice how this is a positive 8? They just keep what's there. But when they go to the negative 8, what do they have to do? Yep, they have to flip the sign because we're going from positive 8 to negative 8. You guys see that? Even on this problem. I should have pointed that out earlier. Here's positive 11. The sign stays the same. But when we go to negative 11, we have to flip that sign. Okay, so be careful of that. I'm going to add 2 to both sides. Yep, 3x is greater than or equal to 10. Divide by 3. Now we just end up with an ugly fraction. So x is greater than or equal to 10/3. Or we're going to add 2 to both sides. Yep, 3x is less than or equal to negative 8 plus 2 is negative 6. We're going to divide by 3. So we get x less than or equal to, that's a positive 3, so we keep the sign, negative 2. Easy. When we know negative is smaller than positive, right? So that's negative 2. The bigger one's going to be 10/3. I'm just going to put 10/3 there.
What if 2 wasn't negative?
You'd have to figure that out. 10/3 is 2 1/3. What is 10/3? How many times does 3 go into 10? 3 times, right?
Right, and then you left off with
1. So it's 3 1/3. Did I say 2 1/3?
Right.
3 1/3.
But that's still.
But that's not logical.
Yeah.
And the
What do you mean it's not logical?
It's supposed to be like a number.
I kind of don't understand what you're saying.
and the fraction bracket though, like for this, that's not logical. I would lose my mind.
You just don't like fractions.
Who does?
I do. I love fractions.
Okay, I'm dealing with fractions in math right now. That are like, you can like, and then I'm dealing with fractions in
I wish I felt sorry for you or something. or problems. Sorry. It's a nasty comment. All right, so I'm looking at the -2 here. I'm going to follow the arrow, or I want all those numbers less than -2. Goes out here to negative infinity. And it gets a bracket because of they both get brackets. Good. This is greater than, so it goes out here all the way to infinity to the bracket. Okay, so my interval notation, negative infinity, it always gets parentheses, goes to -2, and that has a bracket. Guys, knock it off. This one has a bracket.
Doesn't matter which way you do it.
Yes.
It does.
Yes.
So I have to do 10/3 first.
Yes.
Wow, I put -2 first.
No. Negative infinity is smaller than -2. Smaller number, bigger number.
Well, I put -2 first.
I wouldn't, I probably wouldn't take, are you guys throwing glue around in the room?
I don't know if that's wrong, to be honest.
My other class had a real problem with the union symbol.
The U. Oh,
The
yeah, I
U.
forgot about that.
So I said, unless you're going to pre-calc, don't worry about it.
Oh.
Okay.
Oh, wait, what's the math class for seniors?
There's a couple of, you got stats and probability,
You choose.
AP stats and prob. You got QLS, you got advanced algebra, you got trig and pre-calc, or you got calc.
What's the easiest? I don't want any of those, but it's required.
The easiest would be 0 course for your 4th year. That would be the easiest.
But they're required, right?
No, 3 years.
Because you want to go to like
Some
Just gotta have 3 years math.
So if I passed all my class, I don't have to take any math class next year.
Did you do algebra 1 geometry and algebra 2 here at the high school?
Yes.
You're done.
Say less.
say less.
Geometry.
No, bro, I'm looking at my
last year,
schedule.
algebra one, this year, algebra two.
Yep.
Say
Yeah, if you have those 3, you're done.
But
But if you are going on to college, highly suggest taking a 4th year.
So you're telling me right.
Okay, let's do number 1. Okay, the absolute value bars are isolated. So I'm going to take 4x plus 10. I like to do my negatives first, get them out of the way. So I make that +2 a -2. So I'm multiplying it by -1, which means flip the sign. Is this an and or an or problem?
Or wait, how do you tell again? I forgot.
Union.
Less than, and,
Oh,
greater than, or. So what is this?
Well, you flipped it.
It's still an or.
Still an or. You go back to the original.
That's true.
Yeah, go back to the original. That's a great question, by the way. It's a common mistake. I take what's inside 4x plus 10 and keep everything the same. Okay, solve each one. Subtract 10, subtract 10. 4x is less than -12. Divide by 4. Divide by 4.
It's such a big gap. It's such a big gap.
So x is going to be less than -12 divided by +12, -3. Nor. Subtract 10, subtract 10. I get 4x is greater than -8 divide both sides by 4. Okay, x is greater than negative 2. So here's my solution. Graph it. Smaller number is negative 3. The larger number is negative 2. It's an OR problem. Outwards towards the infinities. And parenthesis. How about the negative 2? My interval notations. Smaller numbers, negative infinity. Negative 3. Both have, good. How's that?
But what's that? What am I looking at down there?
Well, these have asterisks to them, so it means something's going on. Why?
It's a negative.
Yeah.
I knew the negative 9. Wait,
Because
oh,
because we have the absolute value bars by itself, right?
Yeah.
That means whatever comes out of there, no matter what x is, x can be a negative billion. But then we take the absolute value of it and makes it positive. Can it ever be greater than a negative number? This will always be a positive number. I'm sorry, greater than.
You just explain it one more time.
When I think you said, I'm sorry, I think it's Siri.
I'm not, that's Android. Knock it off. Go away. Hey, it went away.
You
Is
sound
it?
like
You
Siri.
know the iPhone?
No, it's an Android.
That sounds like Siri. I'm thinking it's Siri.
All right, back to where I was. This is always a positive number. I mistakenly thought that was a less than. It's a greater than. So, what's going to work? What value for x works in this inequality? Remember, whatever comes out of these absolute value symbols will be turned into a positive number. How about a negative million? A negative million times 2 is negative 2 million. Plus 3 is really close to negative 2 million. But then I take the absolute value of negative 2 million, becomes positive 2 million. Is that equal negative 4? Or greater than negative 4?
Wait,
Yes, it will always be greater than negative 4. So what numbers are going to work here? All of them. All the numbers are going to work.
You're confusing me.
All the numbers, values that I plug in for x, no matter what value for x I have, negative or positive, when I multiply by 2 and add 3,
It has to be switched over to a positive.
will always be a positive number. So it's
always
always going to be higher than negative 4. Got it?
I get what you're saying.
Got it?
Yeah.
Got it? Got it? Got it? Got it? Uh-oh. Look at that look. She doesn't have it. Leah or Asia? Asia. Do you get it? Do you get it? Okay.
Are these?
Let me try this again. Let me try it a different way.
Wait, hold on, wait a minute.
What's the absolute value of 5? 5. What's the absolute value of negative 5? 5, right, Asia? Okay. Pick any number for x. Remember, x is just a value, right? So we could choose a value for x. Choose any number. 2.
That's
2 times 2 is 4 plus 3 is 7. the positive value of 7 is 7. It's greater than negative 4. Choose another number. Choose a negative number. Yeah. Negative 5. 2 times negative 5 is negative 10. Negative 10 plus 3 is negative 7. But the absolute value of negative 7 is going to be a positive 7, right? So no matter what I choose for x, whether it's positive or negative, it's always going to be bigger than a negative number. It doesn't sound convincing, but are you good? Okay. So in this case, all real numbers, or shade the whole thing like that, or negative infinity, positive infinity, right? Okay.
No, that's just like, that's great. That's,
Number 3. Again, we got the asterisks again, something's going on, right?
it's like number 2. I just tried.
Well, what do I do first?
Well, first you gotta minus the 8.
Minus the 8.
Right, but then you already have
But
a
then
negative.
you get the negative.
Okay, great. So what so what's my answer here?
Right. I don't even want to go through that process again. Wait a minute. We're just gonna get rid of that. Let's go to the next one. Let's go to the next one.
So what's the answer in this case?
Just go to the next side.
Also no solution. All real numbers. Yes, I knew that.
Again, this is going to be a positive number no matter what. It can never be less than a negative number. Right? A positive number can never be less than a negative number. So there's some thinking going on with absolute value, right? Right? Not good for a Friday afternoon before a football game, right? See? Do you see? You get it? Do you see why teachers have to take all kinds of medication? Okay. Another, I got another quote. That's why teachers can't carry guns in school. Is that a good quote or what? Oh my God, Mr. D. Okay, so I got to add 4 to both sides. I get the absolute value of negative x plus 5 is greater than 10. This one seems not abnormal.
Wait, so wait a minute.
This one seems normal.
How does it seem normal? So the negative has to be after the greater than or what?
Yeah.
For it to be a no.
Yeah. Well, it depends on the sign, too. I thought you didn't want to go there. I thought you didn't want to go there.
Well, I thought it was no solution, but that's some negative, so I was like,
Yeah, but it's negative for the x.
no.
Yeah.
It's 4.
This is negative for...
But you had to
I
add
was
the,
gonna,
you had
right,
to add the 4.
right, but
So
it was
it's
gonna
gone.
be negative. But it was
So negative x plus 5. Let's say I have positive 10. I like doing the negatives first. Negative 10. So I'm going from a positive to a negative. I have to flip the sign. Going back to the isolation problem here, is this an and or problem?
This is an or.
Good. Negative x plus 5 is greater than 10. Now we have to solve these, right? Minus 5, minus 5, negative x
So he's got,
less than negative 15.
what you do now?
Got to get rid of the negative sign, right?
So what?
I'm going to divide or multiply by negative 1. Could divide or multiply, doesn't matter. By negative 1, cancels out.
So it should be negative.
What do I do with the sign? Keep it or flip it?
Keep it.
Flip. Flip. I'm dividing by a negative. We already determined it's an OR problem. Minus 5, minus 5. Negative x. 10 minus 5 is 5. We're subtracting, keep the sign. Got to get rid of the negative sign. Divide by negative 1. So I get x. Flip the sign again. Good. 5. Negative 5, sorry. Yep, 5 divided by negative 1 is negative 5.
No.
Okay, which way do I shade here? Out. Out towards their infinities. Does negative 5 get a bracket or parenthesis? Parenthesis. 15. So I have negative infinity, negative 5, both in parentheses.
All of them are in parentheses.
Yep.
This stuff is easy.
This stuff?
Yeah.
We're not doing this today, right?
You guys are going to do that by yourselves on Tuesday. Yeah, you're going to watch the video.
Look, it's like this.
You're going to have to watch.
Let me explain it to you. Listen to the black guy, okay? So look, you see this, right? This is your x.